So previously, we have seen few of the communication interfaces, including some onboard communication interfaces like I2C bus and SPI bus. And one of the external communication interfaces we have seen is an infrared. Okay. Next communication interface that we are going to study is a very popular one, which you have used and which you are using. That is the Bluetooth. In short, we call it BT or Bluetooth. So this is a low cost, low power, short range wireless technology for data and voice communication. Okay, you can send data and voice over this. It's a low cost and low power and short range wireless technology. It was first proposed by the company Ericsson in 1994. The frequency of operation of Bluetooth is 2.4 gigahertz of the radio frequency, and it uses one of the spread spectrum techniques called frequency hopping spread spectrum. You might have studied this, or hopefully you'll be studying this in DC, digital communication subject, spread spectrum. So there are two types of spread spectrum technology: direct sequence spread spectrum and frequency hopping spread spectrum. Frequency hopping spread spectrum is used in Bluetooth for communication. Okay, the data rate of Bluetooth, it ranges from 1 Mbps to 24 Mbps, and the range or the distance covered, it can be 30 to 100 feet for data communication depending on the version. Okay, there are again different versions in this. So normally we used to say it is 30 feet. Now the advanced versions, they give up to 100 feet range. So the version 1.2, it supports data rate up to 1 Mbps. The version 2.0 plus EDR. EDR stands for enhanced data rate. It supports data rate up to 3 Mbps. The next version is version 3.0 plus high speed, HS high speed, and version 4.0, that is low energy. This supports data rate up to 24 Mbps. Okay, so this can be the different data rates. The Bluetooth communication, it has again two parts. There is a physical link part and the protocol part. The physical link part is responsible for physical transmission of data between devices that support the Bluetooth communication. Okay, so it establishes the link and transfers. Then the protocol is responsible for defining the rules of the communication. The physical link works on wireless principle, making use of RF waves for communication. In case of Bluetooth, it is RF waves of 2.4 gigahertz frequency. In the Bluetooth enabled devices, they contain a Bluetooth wireless radio. All the Bluetooth enabled devices, they will have a Bluetooth radio for transmission and reception of data. The rules that govern the Bluetooth communication is implemented in the Bluetooth protocol stack. Okay, a stack is maintained for the Bluetooth protocol, which governs the rules of communication. This communication IC that is present in the devices that holds this particular stack. So how this data is maintained is each device that is Bluetooth enabled, it will have a unique ID. It will have a unique ID of 48 bits. Okay, so Bluetooth communication, it follows packet based data transfer. Bluetooth supports point to point and point to multi point wireless communication. Point to point means one point to another point, a single point to another point, that is one device to another device. And point to multi point means one device to multiple devices, broadcasting. It's called broadcasting. From one device you are sending data at a time to multiple devices. That is also supported by Bluetooth. The point to point communication, it follows again the same master slave relationship. Any Bluetooth device, it can function as either master or slave. The whenever devices are connected on the Bluetooth network, that network is called a Piconet. A Piconet is a network that is formed of Bluetooth devices. When a network is formed with one Bluetooth device as master and more than one device as slaves, that is called a Piconet. Normally in a Piconet, there will be one master and maximum 7 slaves. One Piconet will have one master and maximum 7 slaves. So this Bluetooth, it is a favorite choice for short range data communication in handheld embedded devices. We use them in mobile phones, right? It's a very popular technology among cell phone users as they are easiest communication channel for transferring ringtones, music files, pictures, media files, and other things between neighboring Bluetooth enabled phones. So before this direct Wi-Fi came in the devices, Bluetooth was very popular for sharing these things, ringtones and music or pictures and other things, right? These days we use some other applications which actually use direct Wi-Fi for communicating or sending the data in between the devices. There is another version of Bluetooth, that is Bluetooth Low Energy. We call Bluetooth LE or BLE in short. It was earlier called Bluetooth Smart also. It is the latest addition to Bluetooth technology. So this low energy, it uh, Bluetooth Low Energy, it allows devices to use much less power when compared to the standard Bluetooth, while offering most of the connectivity of Bluetooth and maintaining similar communication range. The connectivity and the range, they are all similar to what the normal or standard Bluetooth offers, but it uses very less power compared to the standard Bluetooth. So this Bluetooth 4.2, that is the low energy version of Bluetooth. This specification enables IoT support, that is Internet of Things, through low power IP connectivity, with support for flexible internet connectivity options. The internet connectivity, that is Internet Protocol version 6, that is the present standard IPv6. This or is also called 6 low pan. Low pan stands for low power wireless personal area networks. Okay, so low power wireless personal area networks, or Bluetooth smart gateways, and implements industry leading privacy, power efficiency, and industry standard security. So the standards, or the Bluetooth standard, specifies the minimum requirement that a Bluetooth device must support for a specific usage scenario. So this Bluetooth, it is the speciality of Bluetooth is there are different profiles which are used for which maintain different standards. The generic access profile, that is GAP, this defines the requirements for detecting a Bluetooth device and establishing a connection with it. All other specific usage profiles are based on this GAP, generic use access profile. So there are different profiles for different usages. Like serial port profile, it is used for serial data communication. File transfer profile is used for file transfer between devices. HID, or human interface device, it is used for supporting human interface devices like keyboards, mouse, which are connected via Bluetooth. These days, other than USB keyboards and mouse, you also have Bluetooth keyboard, mouses, and other devices which are used for, which act as interfacing between the user and the devices with the help of Bluetooth. So there are different profiles to maintain all these things. So then the Bluetooth Low Energy, or BLE, this also implements various application specific profiles for communicating with low power Bluetooth peripherals like fitness devices, or blood pressure monitors, or heart rate monitors, and so on. So you might have, if you are using a smartwatch, you can connect that with your phone that is using Bluetooth. And what Bluetooth it is? It is Bluetooth Low Energy, BLE. Okay, so there are different profiles here. For example, it is healthcare profiles like HTP, stands for health thermometer profile for body temperature. GLP stands for glucose profile for blood sugar. BLP stands for blood pressure profile for measuring the blood pressure. Okay, so then sports and fitness profiles, which are there in the smart watches or smart shoes or those things. HRP stands for heart rate profile. LNP, it stands for location and navigation profile. RSCP stands for running speed and cadence profile. So these are all related to sports and fitness. So there is another profile called GATT, that stands for General Attribute Profile, which also governs these standards. The specifications for Bluetooth, it is defined and licensed by standards body, that is SIG, Bluetooth Special Interest Group. So earlier, this Bluetooth standard was defined by and maintained by IEEE under IEEE 802.15.1. Okay, so these days IEEE is not maintaining that because it is done by a special interest group or a working group called Bluetooth Special Interest Group SIG. Okay, so this is about Bluetooth. Next kind of communication interface we have, that is, this is also an external communication interface. This is Wi-Fi. Wi-Fi, it stands for wireless fidelity. It is a popular wireless communication technique for networked communication of devices. So this follows the IEEE standard 802.11. So this is actually a wireless version of LAN. LAN stands for local area network. So this Wi-Fi, it is intended for network communication, and it supports internet protocol based communication. That is, you can connect to the internet through this Wi-Fi. It is essential to have device identities in a multi-point communication to address specific devices for data communication. So there has to be identities to each device. If at all there are more than one points or more than one devices connected over the network, so that is called an IP address. In an IP-based communication, each device is identified by a ID. That ID in this particular IP-based communication, we call it an IP address, which is unique to each device on the network. So all your devices which you connect to the internet protocol or IP based communication, whether it is your mobile phone or your laptops or your desktops, when you connect it over the internet, it will have a particular ID, and that we call as IP address. So Wi-Fi based communications, they require an intermediate agent that is called a router or a Wi-Fi router or wireless access point to manage the communications. The Wi-Fi router, it is responsible for restricting the access to a network or assigning the IP address to the devices on the network, then routing the data packets to the intended devices on the network. So it has the data packets that are in the channel, they have to be routed to the proper destination. So that is done by a Wi-Fi router. Or if restricting the access to a network to all the devices, if they are authorized, only then they will be provided access. Otherwise, they will be not provided access. Then assigning the IP address for each devices, that is also done by this Wi-Fi router. The Wi-Fi enabled devices, they contain a wireless adapter for transmitting and receiving data in the form of radio signals through an antenna. So the hardware part of it is known as Wi-Fi radio. Okay, each of your devices, just like there is a Bluetooth radio, there will also be Wi-Fi radio. Whatever the devices support Wi-Fi, they will have a radio for transmission and reception. That is called Wi-Fi radio. And the operating frequency of Wi-Fi is at two different frequencies actually. It is 2.4 gigahertz or 5 gigahertz of radio spectrum. And they coexist with other ISM band devices like Bluetooth. So there are two frequencies of operation, that is 2.4 gigahertz and 5 gigahertz. So along with the Wi-Fi, Bluetooth can also coexist. So they exist with other ISM band devices. What are ISM band? That is one of the bands in the frequency spectrum. That is ISM band. That is called industrial, scientific, and medical. Okay, the frequencies which are used for industrial, scientific, and medical purposes. So this gives a representation of how the devices can be connected over the same Wi-Fi. This is a Wi-Fi router. There are different three devices or three mobile phones are shown. They are connected to the same router. So that means they are in the same network. For communicating with devices over a Wi-Fi network, the device, when its Wi-Fi radio is turned on, searches the available Wi-Fi network in its vicinity. So all these, you might have experienced whenever you want to access Wi-Fi, right? When you turn on, you have to turn, if you want to use it, you have to turn on the Wi-Fi. That means Wi-Fi radio will be turned on. Then it will search the available networks in the vicinity and lists out the SSID, that is service set identifier of the available networks. SSID is the name given by the administrator of the Wi-Fi. So normally, in our college we have AITM1, AITM2, such things. So those are the identifiers. That is the name given to the networks. If the network is security enabled, a password may be required to connect to a particular SSID. So normally, if you turn on hotspot, if you enable the password, then if and some other person wants to access, he will have to enter the password to connect to your network, right? So that is called a password to a particular SSID. So Wi-Fi, it employs different security mechanisms like WEP, WPA, and other things. WEP stands for Wired Equivalency Privacy. WPA stands for Wireless Protected Access. These are different mechanisms for securing the data while transferring over the Wi-Fi network. It supports data ranges ranging from 1 Mbps up to 1.73 Gbps, depending on the standards. There are different standards like 802.11. Again, there is A, B, G, N, or AC, different standards. And again, depending on different access or modulation method. Depending on the type of antenna and usage location, whether you are using it indoor or outdoor, the ranges of Wi-Fi, it ranges from 100 to 1000 feet. So 1000 feet is the maximum range it can provide, depending on where you are using it. So that's about the Wi-Fi, one of the communication interfaces. Next one we have is Zigbee. The Zigbee, it is used as a substitute, or in fact, it is another communication interface, which is used when the range, if you want the range a little higher than Bluetooth. Okay, so it's a low power, low cost wireless network communication protocol based on IEEE 802.15.4 2006 standard. Okay, so this is a standard 802.15.4. Bluetooth is 802.15.1. Okay, so this is 802.15.4, which is actually for wireless personal area networks. So it is targeted for low power, low data rate, and secure applications for WPAN. WPAN stands for wireless personal area networking. So this Zigbee It supports a robust mesh network containing multiple nodes. There can be multiple nodes in the Zigbee network. This networking strategy, it makes the network reliable by permitting messages to travel through a number of different paths to get from one node to another. Okay, so it uses a different strategy. That means it can use more than one path because it's a mesh network. It can use more than one path to get to the destination from one node to another. So this operates worldwide at the unlicensed bands of radio spectrum. So there are different ranges or different bands of frequency which make use of Zigbee, in which you can use the Zigbee, that is 2.4 to 2.484 gigahertz, then 902 to 928 megahertz, and 868 to 868.6 megahertz. So these are the different bands of frequency at which the Zigbee operates. And these are all unlicensed bands. You do not need to have license to use these bands of radio spectrum. And the range of operation is, it supports an operating distance of up to 100 meters and a data rate of 20 to 250 kbps. It is little lesser compared to the advanced versions of Bluetooth. So here in Zigbee terminology, each Zigbee device, it can fall under any one of these. So it can be a Zigbee coordinator or network coordinator, or it can be a Zigbee router or a full function device, or it can be a Zigbee end device or reduced function device. The Zigbee coordinator, it acts as the root of the Zigbee network. Okay, so it initiates the network. Actually, it is responsible for initiating the Zigbee network, and it has the capability to store information about the network. It is like a master in Bluetooth. Okay, here we call it the coordinator. Then there is a router or a full function device. This device is responsible for passing information from device to another device or to another Zigbee router. Okay, from one Zigbee router to another Zigbee router. So then Zigbee end device, or it is called reduced function device. So end device containing Zigbee functionality for data communication. So it is the end device. It can talk only to a Zigbee router or Zigbee coordinator. One Zigbee end device cannot communicate directly to another Zigbee end device. So if a Zigbee end device wants to send something to another Zigbee end device, it has to be through a Zigbee router or Zigbee coordinator. Okay, so it doesn't have the capability to act as a mediator for transferring data from one device to another. So this is the model of a Zigbee network. So this Zigbee coordinator is the network coordinator. Then there are two Zigbee routers. Okay, so then you can see to this Zigbee router there are three end devices connected, ZED, three Zigbee end devices. Through to this, this is a Zigbee router. To the Zigbee coordinator, there are directly two Zigbee end devices connected. Okay, so this way the devices are connected. Now, for this Zigbee end device to communicate to this Zigbee end device, it cannot communicate directly. It has to be through a Zigbee router, through this path. And for this Zigbee end device to communicate to this Zigbee end device, it cannot be directly. Again, it has to be through this Zigbee coordinator. Now, for the Zigbee end device, for this Zigbee end device to communicate to another Zigbee end device, which is not connected to the same router, then it has to go through this router, then to the Zigbee coordinator, and then to the Zigbee end device. So this is the way in which it communicates. What we mean to say is two Zigbee end devices cannot communicate directly with each other. The communication has to be through a Zigbee router or Zigbee coordinator. So primarily where we use this in applications like home and industrial automation or energy management or home control and security, medical or patient tracking systems, in logistics and asset tracking, and sensor networks and active RFID. So these are all the applications where we can use this Zigbee, like automatic meter reading, which can be employed in the electricity meters or power meters, then smoke detectors, wireless telemetry, HVAC control, which are used in industries, okay, or some buildings. HVAC stands for heating, ventilation, and air conditioning. Okay, these are one of the requirements which the buildings have to satisfy. Okay, the control of that can be achieved using Zigbee. Heating control, lighting control, environment controls. So all these are the applications where we can use Zigbee. So again, for the Zigbee, the advanced version of Zigbee, it's called Zigbee Pro. Zigbee Pro, it offers full wireless mesh low power networking capable of supporting more than 64,000 devices on a single network. It's a pro version of Zigbee. It provides standardized networking designed to connect widest range of devices in any industry into a single control network. It can support up to 64,000 devices on a single network. It offers an optional new and innovative feature which is called green power. Green power, which that means it is a batteryless. It is used for batteryless devices. Okay, so it's called green. It doesn't use any power. It's an eco-friendly thing to connect energy harvesting for self-powered devices into Zigbee Pro networks. The green power feature of Zigbee Pro is the most eco-friendly way to power batteryless devices. Yeah, like sensors, switches, dimmers, and many other devices, and allows them to securely join Zigbee Pro networks. It's called green because it doesn't use any power, or it's self-powered devices. Then there is another version of Zigbee, Zigbee 3.0, 3.0. It delivers all the features of Zigbee while unifying the Zigbee application standards found in Zigbee devices. Okay, so this enables communication and interoperability among devices for smart homes, connected lighting, and other markets. Okay, so these are the different applications. So again, to manage or govern the Zigbee standards or Zigbee specifications, we have a group called Zigbee Alliance. It's called a consortium. That means a group of different. It's a non-profit consortium of leading semiconductor manufacturers, technology providers, and OEMs. Stands for Original Equipment Manufacturers and End Users Worldwide. Okay, so this Zigbee Alliance, this develops and manages the standards or specifications for Zigbee. Okay, so with this we have completed the third module of this particular subject. The third module we have seen embedded system components, right? So if you have this, these are the textbooks, this is the actual textbook, Shibu KV. Yeah, Introduction to Embedded Systems by Shibu KV. Both the editions are there, first and second edition. So we have seen, if we have to just revise this particular subject, we have started with the definition of embedded system, differences between general purpose computing system and embedded system, then classification based on different parameters or different criteria based on generation, complexity and performance, deterministic behavior and triggering, then major application areas of embedded system, then different purpose of embedded systems. Okay, then the typical embedded system and elements of typical embedded system or elements of an embedded system, then different differences like CISC versus RISC, Harvard versus Princeton or one Newman architecture, then big endian versus little endian, right? Then we have come to the memory. Memory, we have seen memory classification, that is ROM and RAM. Again, in ROM there are different types: mask ROM, OTP, EEPROM, EEPROM, and flash and NVRAM. In RAM we have seen static RAM and dynamic RAM. Then we have come to sensors and actuators, the definitions of them, and one of the IO devices we have seen is optocoupler. Then we have come to the communication interfaces. In communication interfaces, we have seen onboard and external communication interfaces. In onboard communication interfaces, we have taken an example of inter-integrated circuit bus, I2C, and serial peripheral interface, that is SPI. In external communication interfaces, we have seen IRDA or infrared, Bluetooth, Wi-Fi, and Zigbee. Okay, so these are the different things. Previously, we had some other things like some other circuits like reset circuit, watchdog timers, and other things in the syllabus, and even embedded firmware, how embedded firmware is developed and all. So those embedded firmware part we will see in the next module, that is in the fourth module. Okay, so again, repetition is not required over here. So in the next class, I will begin with module 4, that is embedded system design concepts.